So the last 2 days, we have been working on factoring with these special patterns. On Tuesday, we did factoring with the difference of perfect squares, where we had a binomial and they were both perfect squares, like x squared minus 9. And then yesterday we were working with trinomials. So they had 3 terms and we were factoring them with the 3-term pattern, the perfect square trinomial pattern. So the homework that you had contained both. And we did start the homework together yesterday in class, kind of first going through which problems was the stuff from yesterday. And then of course, also which problems had a GCF. So we kind of looked at those. Today we're going to review both forms, practice both forms.
It's a lot of action going on.
So we will look at both forms of these perfect square factoring. It's really quick, short factoring compared to the method that we were using prior to. But the reason we can do that is because the numbers are special numbers. It doesn't work for every single problem, which is why you use it last, because actually the factoring that we were doing last week works for any problem, right? This is only special cases. So there is a worksheet today that will kind of give us a review, and then you'll have a quiz tomorrow. So a small quiz tomorrow at the beginning of class. We'll work through a couple of problems together. There will be a little quiz on this, just this type of factoring. And then there will be no homework tomorrow. I should have put on here that there was a quiz, but yeah, quiz tomorrow. So Mr. King, do you want to go over some homework problems and then I'll go over some review problems? So if you want to take out your homework, Mr. King will go through a few homework problems with you. Of course, that didn't start. And then I will look at a few review problems with you. I gotta get my Zoom going again.
Sound on?
Yes, the sound is on. Got that going. I've been pretty good with that lately. The sharing part stopped. Okay.
Yeah. Thank you again. What is happening?
Okay.
Now we're cooking.
I think.
Now we're cooking. Okay, which one that we could do together? Yeah. 9's a good one. 9's a real good one. So 9 says 25w squared minus 20w plus 4. First, we look to see is there a GCF. We already went through these and we know there's not a GCF. So now we take the difference of squares. TJ, what is the square root of 25w squared? And what is the square root of 4? Good, so 5 and then w and then 2. Now, TJ, when we write our final answers, is it going to be 5w plus 2 or 5w minus 2? Look at that middle term. Yeah, 5w minus 2 square at the bottom. That's it. That's all there is to these problems. Let's do another one. Mr. Corn, why don't you give us one to do? You said 13? Wonderful. So 13 has a GCF to start with because 6 isn't a perfect square. 24 is not a perfect square. All right. When you're going through these, you could either make a little factor tree and see what the perfect square is, or you could just think, in this one, what number kind of sticks out as being your easy GCF? 6, yeah. So it is 6. A lot of times it's the first number or the last number. Like a lot of times we'll see 3w squared or 2w squared, or at the end you might see a 2 or a 3, and that gives you a nice easy way to get to GCF where you don't have to do that factor tree. So we're going to take out a 6. when you take out a 6, what's left, Bill? Yeah. Mm-hmm. Yep. Well, what's your A, what's your B? A -1, but 1. And then now is the part where you get that negative, because you're going to get 2W minus 1. That whole thing is squared, and then what can you not forget? Yeah, the GCF. You bring it down. That's it. Good. We'll do one more paint. You got one you want us to do together? One you didn't get to? Yeah. So 7, we first looked, does it have a GCF? In this case, it does not. Anya, what's my A? What's my C? Sorry, my A and my B.
A would be 3C and B would be 4.
You got it. Is it going to be addition or subtraction in the middle of that?
Addition.
Yep. That's it. That's all there is to it. It's that 3C plus 4 quantity squared. When you look at number 4, notice that both 4 and 64 are perfect squares, but they have a GCF. The GCF of these is 4. So we could take a 4 out, and then we're left with y squared. And I gotta do my math. Let's see. 16.
Good.
So now you get y is your A, 4 is your B, and then it's a difference of 2 squares. So we get y plus 4 times y minus 4, and then don't forget that GCF in front. If you just took the GCF, I'm going to put this in red, you would have got 2y plus 8 and 2y minus 8. And then you would have to factor out each of these. You don't want to do it that way. So I'll always look for the GCF first.
So every question, the first thing you should look for is there a GCF? Do they have something?
Questions?
Today was a practice day. We are going to practice 6 more problems.
Ooh.
In your packet, there are a few more problems remaining. So if you would turn in your notes packet to page 35, pretty sure that it's page 35. So get out that physical packet of notes if you're in here. If you're at home, it's page 19. But we're looking at the checkpoint problems, the remaining 6 review problems, practice problems for this section 5.5. Is it page 35? Yeah, yep, down here, yep. So physical packet, it's page 35. And there are 6 problems at the kind of like halfway down where it says checkpoint. Again, if you're at home, this is page 19. So we did example 3 and 4 at the top together yesterday, and we're just going to go through these review problems together, the checkpoint problems. So looking at the first type of problem, there are 3 terms. So this is the factoring we did yesterday. The first question, is there a GCF? So we have an x squared, a 10x, and a 25. That's the first question you ask yourself. And if you say no, Then the second step is to say, all right, what's A and B? And there is not a GCF. So Bill, if we're looking at 5x squared plus 10x plus 25, what is the A and the B? Right, x and 5. Now you're going to have to remember there are 3 terms. So when we factor with 3 terms, your answer should be 1 parenthesis squared. And then Bill, what goes inside that parenthesis? Why did you say plus? Yeah, so it's a positive 10 in the middle. So when you factor it, it should be a plus. So when you look at the 6 problems, all of them except number 9 have 3 terms. So your answer for all of them except number 9 should look similar to number 5. So looking at number 6, we have 4x squared plus 12x plus 9. Peyton, the first question, do 4, 12, and 9 have anything in common? Is there a GCF between 4, 12, and 9? No. So don't have to worry about that. Then we're going to say, what is A and B? So Peyton, A is, and then the variable x, and then B is 3. Yeah. So this is going to have the same form that Bill gave us. And Peyton, what does that look like inside those parentheses? Yeah, so it's 2x plus 3, and then that quantity is squared. That squared really means there are 2 parentheses that we would FOIL and multiply together. When you're factoring, probably 90% of the problems have 2 parentheses that you're multiplying together. The only time they wouldn't is if there was just a GCF to take out. That there's 2 parentheses that you really FOIL to get back to our original problem. Any questions with 5 or 6? So checking out number 7, again, first question, is there a GCF? And we're looking at 9, 24, and 16. So 9 is only 3 times 3. 3 can go into 24, but 16 cannot divide by 3. So there's no GCF. So Emma, since there's not a GCF, what is A and B? Good. So A, 3P, and then the B is 4. And Emma, what would that look like factored? Nice job. And then quantity, parentheses, squared. And you said minus because? Yeah, there's a minus 24. So that's why we have a minus inside. Sorry, Mr. Cummings, I just saw you. Otherwise, I would have got it. So none of those had a GCF. But if we look at the next group, I see some GCFs in the next 3 problems. Number 8, 5x squared plus 10x plus 5. Nakai, what do you think 5, 10, and 5 are all divisible by? 5, yeah. So the GCF here is a 5. So divide out 5, divide out 5, divide out 5. So that's the GCF. Nakai, when you divide by 5, these 5s cancel. So that means what do you have left? Yep. And then Nakai, 10 divided by 5 is? 5 divided by 5 is? Not 0. What's 5 divided by 5? 1. Yeah, there's a 1 there. So 5 divided by 5 is 1. That's a sloppy looking one. So we still need to factor this. And I know it looks weird inside, but we still have an A and a B. Jason, what do you think A is? And B is? Yeah, and that seems weird. So there's an x squared. Well, the A is just x. And then the B, 1 times 1 makes 1. 1 is a perfect square. That kind of seems a little weird that it's just the number 1. But 1 times 1 makes 1. So, Jason, your final factored answer would be Nice. So he had the 5 for the GCF, and then x plus 1, and then it's squared. So take out the GCF, list your A and B, and then it's a plus because it was a plus in front of that 2x, positive there. All right, number 9 is the one that's different than all of the others because there are only 2 terms. The first question, is there a GCF? TJ, 8 and 18, is there a GCF? I'm going to say yes, because they're both even. So if we have 8 and 18, what do you think they're both divisible by? It's a small number. 2, yeah, they're both divisible by 2. If you take out a 2, TJ, 8 divided by 2 is, and then 18 divided by 2 is 9. So same process to start. Take out the GCF, and then we need to decide A and B. Michael, do you know what the A and the B values are?
A would be 2y and B would be 3.
Excellent. And then Michael, this one is different because it's just 2 terms. Do you remember what this looks like when you have 2 terms when you're factoring it?
Would you do 2y plus 3 and 2y minus 3?
Awesome. Nice job, Michael. And then bring down that GCF. Nice job. So like a little trick to remember, 2 terms, 2 parentheses. So 2 terms, 2 parentheses, the first one plus, the second one minus. And the reason we have 2 parentheses is because that's the only way I can get a minus sign, by multiplying a positive times a negative. When it's a positive, they're both plus or they're both minus. But that's why you have 2 parentheses, because that's the only way with multiplying that you get a negative number. Any questions with that? So the last one on here, 12u squared plus 36u plus 27. Anya, is there a GCF? This one's a little tricky. So 12, 36, and 27.
Would it be 2?
How about one more than 2? Because 27 isn't divisible by 2. But what would be one more?
3.
Yeah. So it's a 3. That one's a little tricky. So 3 goes into 12, 3 goes into 36, and 3 goes into 27. And a way to kind of think about that is if you have 12, you can always list those factors. And the factor that contains the perfect square is 3 and 4. So I want to divide by 3 so I get the perfect square of 4. Emma, if we divide these by 3, what do you get when you divide 12 by 3? And then 36 divided by 3. And 27 divided by 3. So notice by taking out that 3, we now have perfect squares. Every problem we factor, you have to have a perfect square in the front and one in the back. So Peyton, what is the A and the B here? And B is awesome. So 1 parenthesis because there are 3 terms. That 1 parenthesis is squared. And the reason there's 1 parenthesis is because I have a plus at the end. 2 negatives multiply to be a positive. So we would have 2u minus 3. And then don't forget the GCF. And on the last quiz, I don't think anybody forgot the GCF. Like everybody remembered that. So Mr. Kane, you must be doing a good job enforcing that GCF. I know, I don't give you too many compliments, huh? I guess I need to give you more.
I love it.
Yeah.
See, that's why tennis club or tennis conversation.
Aha. There we go. Any questions? So I said today is just a practice day. We are gonna travel over to Google Classroom. And my hope is that you get almost all of your homework, if not all of it done, before you leave class. So that everybody gets it finished, submitted. And ready for the quiz tomorrow. And tomorrow's quiz is, I mean, these problems are quick. It's not going to take you too long. So on Google Classroom, when you go to the stream, again, the first part of the stream is the homework, section 5.5 review worksheet. That's what we're looking at. And before I hand this over to Mr. King, we're going to just fill in those top 3. And that might help you remember if it's 2 terms versus 3 terms. So this worksheet has 24 problems. Yikes, 24 problems. But they're fairly quick and you're going to have the entire period to work. Mr. King can go through a couple with you, or he can kind of say, remember, this one has a GCF, this one doesn't. But just at the top, filling in these patterns. The first one is 2 terms, so your pattern should have 2 parentheses. So this is the one with the plus and the minus. That's the pattern. So all of your equations that have 2 terms have 2 parentheses, and I didn't write a minus. There it goes. The middle one has 3 terms, but there's a plus in the middle. So this is a plus b squared, and that plus tells me there's a plus in my parentheses. And then the last one is a minus b. Again, that minus tells me there's a minus in the parentheses.
Okay, so we're gonna go through some real quick, just to give you a little bit extra time, and we're gonna go diagonally. So we're gonna do 1, 5, 9. And then we're going to bring it back 11, 13. Okay. So number 1, we first look for a GCF. Bill, is there a GCF in 16 and 25? No. Okay. So what's my A? What's my B? 4x and 5. Good. What's my final answer? Good job.
Real quick notice.
We're looking at number
Under a minute.
under a minute. We're looking at number 5. Peyton, is there a GCF?
What number is it?
5. No. What's my A? What's my B? Good. So we're gonna have x and an 8. A thing's gonna be squared. Are we gonna do minus or a plus? Yeah, we're gonna do a minus because of that middle term. Good. Next, we're gonna do 9. TJ, is there a GCF in 16 and 49? 4 doesn't go in 49, but that was my first thought too. There's actually not a GCF here. So what's your A, what's your B? Good, 4x and 7. Is it gonna be a plus or a minus? X minus 7 quantity squared, good. We're gonna snake back and do 11. We're doing all diagonals, all diagonals. Jason, what's the GCF of negative 7x squared plus 140x minus 700? Not just 7, but negative 7. We're gonna get the negative out. So Jason, when I get that negative 7 out of there, what's left? 20x, yep. Yeah,
A nice job switching your signs. Be careful when you're taking out a negative there.
100%. What's your A, what's your B? Good. What's your final answer? Good. Set -7, so you brought your GCF down. And then you're left with the x minus 10 quantity squared. This is your final answer. So that was the hardest one I think we looked at so far, and you did a stellar job. Stellar. Okay, let's look at 15, number 15. Does it have a GCF? No. What's your A, what's your B? Well, just x. And then what's the square root of 169? If you guys have your sheets, it really helps to have those out.
And the common power sheets, we will really use.
And you use that on quiz too.
They're really helpful. Then you don't need to look up the number in the calculator, you just find it on the sheet.
Yeah. You got that? You turn it sideways. If anybody's using an iPhone, you turn it sideways, they have the square root button. Okay, so that's going to be 13. So it's a difference of two squares. So you're going to get an x plus 13 and then an x. That's it. Let's do next. We're snaking back to 17. 17. Emma, what's the GCF in this case? Good. 8. So you take 8 out, you're left with x squared minus 9. What's your A? What's your B? Yeah, x and 3. So you're going to get, what's your final answer to that? Well, remember, it's only 2 of them. So when there's 2, you get 2 answers. So this one, you get x plus 3, x minus 3, and don't forget that 8. Keep that there. TJ, 19. Is there a GCF? What's your A? What's your B? 5x and 1. What's your final answer? Remember, when there's 2 terms, you got to do the difference. 5x plus 1 and 5x minus 1. So that's something that we got to look out for. So like the one below TJ in class is the one you would have the minus and then the squared. So if you look at that minus 36x, since there's a trinomial there, that's the one where you just have your answer squared. All right, last one we're looking at. Number 23, Jason. Is there a GCF? No? Okay, good. What's your A, what's your B? What's your final answer? So, you got a good little jump. You still have 7, 8 minutes left. Please, now's the time to ask questions.